Hello, it's Michael again, doing some more live coding on my game engine. Last time I left off, was it yesterday or the day before? Yesterday. I think it was yesterday. Yes. I had been working on the text writer API, which was a method with which you can stream out the contents of a text file in a safe way. So by that I mean that instead of writing directly to the destination, we write to the temp folder on Windows, or the temp folder in the I think it's in like the library folder of Mac OS somewhere. And then once the destination, or once you've completely filled up the file in temp location, it copies over atomically to the final destination. And that allows you to protect yourself in case of things like power outages or app crashes or any number of things that might interrupt your save. Now, where I left off, I had been working on overloading the insertion operator, the two arrows to the left that looks like this. So that way you can just construct a text file writer, and then just shift out all the stuff that you want to save, kind of like you would with stdc out, but it goes to that temp file, and then when the file closes, it'll move it. And I was running into a bit of a hurdle with outputting things that needed overloads. And offline, I spent some time earlier today reviewing what I did, and I realized there was a much easier way to do it. So now I've got the text file writer set up in such a way that you can open it just like before. You can shift out anything that you need, but it does support anything that supports stdc out. So if you, for example, I have an example down here, the vec3 class, which is a class that I wrote a while before. It is a struct with 3 members in it. You can now overload the ostream operator. So if I go to that operator as an example, I got an inline ostream reference returning operator with ostream on the left hand side. Now I can use this operator overload when writing to the writer. So if I was to run this program, the program launches like normal, and this example file was created in the temp folder, moved to the user folder, and if we take a look at the contents of it, we can see that the empty vector 000 printed out to the console using the formatting I got with that operator. The way that I did this was by simply templating the insertion operator on the writer class. So let me find that real quick here. In the IntelliSense thing, make it go away. Now this is a little more complicated looking than a simple template. It's got this enable if type for the return type. But the gist is that I have an operator that takes any type as the data, and then no matter what the type is, we construct a stream. We use the ostream operator upon it, so we get the ostream operators to work, and then we output that contents of that string to the file. And that works quite well. I had to go a little bit further though, because when you overload an operator for all types, that means that IntelliSense or the compiler won't notice right away whether the function will work. So if I didn't have this, if I just replace this whole thing with the text file writer reference, like that, functionally this would behave the same, except I could then insert things that don't belong. So I've overridden the operator for MathVec3 for testing purposes. It's the only class in my math library that I've done that to. So if I was to use Vec4, I don't want to be able to have a developer type something like this on some class that they want to write, and then they think that it's all good. Because without the templated return type on the operator for the text file writer, that's technically a function that accepts all types. That is, there's a template specialization for every type. So this would look fine. It wouldn't actually cause any errors with the IntelliSense, but somebody goes to press F5 to build it, they'll find that there's going to be a problem compiling. And that's because while the outer function, the outer operator for text writer supports all types, inside that operator, we are using string stream to receive it. And if it's a thing that it's not compatible with string stream, the problem occurs not here, but within the operator. You can see that there's an error here. So in order to make this more clear, because like even after the compilation error occurred, it's not telling you that this is where the problem is. It's saying that the problem is in file.h. In order to make that less of a problem, or to eliminate that problem, I threw in this template specialization detail. So enable if is a powerful STD mechanism by which you can conditionally create types. So enable if allows you to put a condition on the left-hand side, and the value will only be present in it when that condition is true. So in this case, I've got another helper type specialization condition. I'm not sure if there's an actual term for that, where if this condition is true, then the enable if type will exist for text file writer. So this operator only works if the type T has an insertion operator. And now if we look back in here, we can see that we have the red warning that says no operator matches these operands, the left being the text file writer and the right being Vec4. That's crystal clear. That warning doesn't appear on Vec3 where it's totally safe. If you go to compile, the error should be pointing towards scene manager dev state, the actual place where the problem occurred. So it's a pretty important piece of code, and that's not a standard library thing. I had to I found an article on Stack Overflow, or a question on Stack Overflow, where somebody had figured out a metaprogramming way to determine at compile time whether a type has the insertion operator. We can see here if we go to the error list, now it's saying scene dev state CPP, the place where the code is actually bad, is not working. So yeah, that's a pretty big steps on the file writer that needed to get done, and it's dramatically simplified the code as well. Going back into file.h, we just have this single template for the insertion operator, and I just straight up did away with the file operator, or text file writer.write. The write function I don't think is very useful. People can just shift out like this, and it's just so much more practical. However, looking at this code, I've realized that there's kind of a problem with the way that I am saving data to the file. And people who are more experienced with C++ probably would be able to spot this right away. And the problem is that every little thing that we insert into the stream using operator, the left insertion operator, every little thing triggers fwrite. So every little thing writes to the file. And you would think offhand, sure, that's probably what you want. You want everything to be written to the file, but it's not very efficient. You want to reduce the number of operations you have writing to disk as much as possible. So what's actually a lot more common, and this is the case with the standard library file stream stuff, is that it's better to maintain a buffer of data that you want to go out and then periodically send it out. That's an operation called flushing. So right now, the text file writer works great. It does everything I need it to, but it's doing it in a pretty naive way, and I need to address that at some point. And I figured that while all this is fresh in my head, now is a good time to go ahead and take care of it. And I think what I'm going to do to address this is to just do away with fwrite and fopen and fclose, and I'll move to the std ofstream class, which is the C++y way of outputting to file. ofstream. Here we go. Where basically you just create a helper object that's a lot like it serves. There's obviously a lot of overlap between it and what I need, which is why I decided to implement it. But basically, you create the object, the ofstream. You open a file with it, and you use the shift operator to send things out. This is pretty bread and butter stuff. But I've realized that while I do have some needs that I need to meet that it doesn't meet on its own, the down and practical writing data out is handled exactly the way I want it in the standard library version, and I'd rather use that instead than have to do platform specific fopen, because with Windows and Mac they disagree on whether you should fopen or fopens. So what I'm going to do tonight, we'll see if I can pull it off in the next hour or two, is replace all that writing code with basically a wrapper for operations to ofstream, and then have ofstream take care of buffering and then flushing the data periodically. All right, so the first thing I got to look at is the open options. So open, this is kind of spread out a little bit all over the place because some of these functions have to be platform specific because of the way I wrote them. Going into text file writer open, we can see one of those, the very first operation, fopens, can't be handled the same way that fopen is on Mac, because they're written in different ways. I have to get the error code from the return value and so on and so forth. So I kind of need to scrap almost all of that, probably all of that actually. I don't need to do error code checking in this way. So at the very least, I'm going to be commenting those out until I don't need them. And then looking at the file path stuff, open. The temp file path stuff I need to keep. This is platform specific, so I think this function will, it may need to remain platform specific. I'm on the fence about that. Let me think about that. Well, getTemp file name needs to be called once per open, but the end result is always a UTF-8 string with the file path that I need. So what I might do is I might wrap this in a platform-specific helper call, and then move file open in here, and just reach out to it to get the path by itself. Then the rest of it can be platform generic standard library stuff. So let's do that. First, let's go to file.h, and we'll go down to the private stuff. I will do, I think I'll need to put this in between these and these. I try to order these in terms of what's needed for the next thing. So content dir path, user dir path, and all that stuff I have right above the functions that set them. I'll do it right here. So it'll be static std string, and we'll be getting the get temp file path, or get new temp file path. I guess that's probably the, I want to make it, you know, clear that I'm not talking about getting the existing temp dir path. This just means I need a, or maybe file name would be better. Get new temp file name. Yeah, and then in the implementation, I'll just have to remember that it also includes the path. I don't know, file path can sometimes refer to folders, can sometimes refer to files. I'll use file path, and then we'll take in, copy that. And in here, where I was going to have the open functions, save text file, load text file and save text file, where it just does the whole file at once instead of streaming in and out. I think I'm going to leave those identical. I have no reason to change them. They work great. So I got an std string, and we got to put in the file text. Oh wait, top file namespace. That's right. This is a private function, but it's going to contain the platform specific stuff. So first, let's grab the code. This is the file reader, not the writer, so it doesn't have the temp file stuff. Here it is. I need destination file path equals, that can stay. I think this is all I need. I'm going to control exit. There we go. mtemp file path was the member of text file, the private member of text file writer that tracks where we are currently writing to, meaning the file in the temp location, not the destination that will ultimately move it to. So in this case, instead of doing mtemp file path equals, I'll just return it, return this value, and then here I'll do temp file path equals get new temp file path to invoke the platform specific stuff. Now, just like that, this whole thing can be popped back in file.cpp, and I won't have to rewrite it from Mac. I will cut it, and we'll go to, I think this will need to be text file reader, file exists, text file reader, close, read next line. Yeah, it's going to be below here. Those are the helpers. I guess I don't have any text file writer stuff in here anymore, but here's that definition. We got file error code that we're returning text file writer open, got the virtual path, and then this logic works fine. First thing that happens is we confirm that the handle isn't already open. The way that text file reader and text file writer handle this is that if you tell it to open, so if you have an existing writer and then you say writer .open, you can switch to another file without thinking about closing the last file. It will just automatically close the last file. So if we go back to file.cpp, I'm going to make that one line because it's simple enough that it's easy enough to read. We close the previous file if it's already open. Then we get the destination file path, which, what if I should rename given what it's supposed to be? This is the destination file path in the virtual space, in the virtual hard drive, the text file writer tracks the platform specific, or the absolute path to the file that we're going to be saving. So and so is this. This is also an absolute path. I guess I could say, yeah, I'm going to rename these. I'm going to do Control RR. Do me some destination file native path. Okay. Yeah, it's sometimes a little dodgy, picking up all the right places to replace. So I got to inspect it each time. Yep. FOpenS. We're not going to be using FOpenS anymore, but fine, go ahead and replace it. Apply. And then I'll do the same thing for temp file path. I'll make sure that it's clearly noted that it is the native path and not the virtual path. Yeah, okay, cool. And I'm just going to move these up to the top. I'm not going to bother commenting them because they're actually pretty simple. But now we're going to be doing, now that we've got the paths, we've got a valid path, and we've got the native file path. And because of the way that the implementation works on this function on Windows, is that this actually will create the file too. So when we go to open the file to write to it, the file will already exist. I'm not sure, depending on how the macOS API handles it, I'm not sure whether I will need to give consideration for opening up the file from here. Maybe on the macOS version, I might need to, for example, manually create the file in the get new temp file path. I don't know. Well, that's a detail that I'll deal with when I go to build this on Mac the next time. For now, we've got the path, and now we've got to open up the temp file. And this is where the code differs considerably. To do this, I'm going to need an std OF stream. So I'm going to actually make that a member of the class, because we're going to need to hold on to it while we're working with the file. That's going to be a private member. So I think these, yeah, those paths, those need to be fine. Those need to be there. M is handle open. I might not even need that anymore, because if OF stream has a call to is open. So because I'm going to be just basically wrapping an OF stream anyway, I no longer need that. I can just go to I think there's a call for checking it. Get last error open. Oh, do we? Oh, okay. I guess I don't have I didn't implement like a checker call that says like is open or something. I don't think I need one, but the point is that when we go to check whether it's got a file open, we just invoke is open on the OF stream. We no longer need the file pointer. The error code, I suspect, will probably still need a way to track whether the opening of the file was successful. Yes, yeah, we will. I just don't know whether the form will change at all now that I'm not using the Windows API. But I do need it specifically because while the open operation does return an error code, I need to hold on to it, because if you are constructing with the path being passed to the constructor the way that it did here, where I just create it and give it the path to open immediately, that can't return anything because it's a constructor, so we have to hold on to it so that we can call we can check on whether the file opens successfully later. Yeah, and let's go back to the private members. So we'll need to do an std OF stream, and I think I've got the header in for this already. I think it's probably one of the header libraries I use includes OF stream. I'm not 100% sure. I've got a lot of standard library stuff in my precompiled header, which, like, this project's already at the size where you can't really fit all of it in your head at once. So I must have added it at some point. Yeah, I've got IO stream in there for some reason, or F stream. I forget. I think it's F stream is the one that gives me. Yeah, it's included from F stream. So I've included F stream for some other reason, and I still have it in the header, so I don't need to add it. So we got an OF stream, and I'm gonna do m underscore to remind myself while I'm coding that it is a member, and we'll do stream, I guess would be the easiest way to remember it. And now we've got one. I need to set it up. So if we go to the open function, which is invoked by that overload of that constructor that takes the path. Here we no longer have m is handle open. We now use mstream dot is open, and that will return a bool whether the file is open, and that's just how it works out of the gate. Now we're gonna have to open it. We've already got the temp file path, which is where we're going to be working right now. We're going to go mstream dot open, and I think it's as simple as just passing it the file name, right? Yeah, const std str. So, and I do need to provide an open mode as well. So we're going to do the temp file native path, which we keep as a member because we need it when we go to move the file, when we go to close the copy in the temp file. And then the open modes, I don't do this all the time, so I'm having to look up every little thing. Mode. Okay. It's a bit mask, so we're going to make a bit field and combine the things that we want. We want this to be output, right, out to the file. Sometimes I get confused in my head whether they're talking about into the stream or out to the disk. I think it's out. I don't need binary. I'm doing it in text mode. And we're not appending. The way that I imagine this API would be used primarily will be to just replace the file if it already exists. Yeah, I think that's oh, that's interesting. So truncate. So I can actually just specify trunk in the open mode, and it'll take care of deleting the contents of the file for me, which is great because I was manually doing that before. So I just need I just need out and trunk. That's all I need. It's called iOS base. Oh, I have to do std iOS base. Yeah, and then somebody asked me a couple of streams ago why I don't use namespace std, and I think it's just that like I do this so very little that it's not worth it to me to pollute the global namespace. We need trunk, right? Why are you yelling at me? Must be a class or namespace name. Is it not though? Isn't open mode an enum? Oh, it's a public member type. constants defined as public members. So it sounds like they are not constants in the namespace, they're constants of a class. Does that seem right? I don't know why it would be. iOS base open mode is a it's a type def for an int, or an alias for an int. So how do I specialize for a trunk? Is trunk just part of the okay. So I guess it's just part of the iOS base space. So std iOS base and out is what I need. Was there another parameter I needed to provide? I don't think so. Check my bases real quick. File name mode. No, that's it. Cool. And just a stippler for detail. I'm gonna put it here before I bitwise and them together. So that's that. The file is open at the native path. If it already existed, then it will replace the contents. That's what truncate does. Though now that I'm thinking about it, last time I did this, I needed to make sure that the file actually, or that the intermediate folders actually existed. So did I preserve that in the, when I moved everything to get new temp file path? No, I didn't. So I know that at some point I needed to create the destination folder. Oh, you know what? I remember now. That logic is put inside of the set data paths location now. Backslashes to slashes. And then down here we use the file system API to create the directories, because that's just the easiest way to do the directory and all the intermediate directories the whole way down. Cool, so that's good. Coming back to open. Now, do we actually need to do anything else? I guess we gotta check the error code. And then that's it. All of this was just error code stuff from the fopens. Cool, so we go to open up the OF string. We need to check for its error code. Format flags, that's not it. Mode. Surely there's just a query function. Shows you how often I do file stuff that I don't even have this memorized. Good? Oh, good. Maybe that's it. Returns true if none of the stream's error state flags are set. So first, I guess what we'll do is we'll do is good if mstream dot good. Well, I guess if mstream is good, then we just move on. So we'll say if it's not good, what if they have a bad function? They do, they have a bad function. That's fun. All right. It totally could just use not good, but I'm going to use bad instead. Returns true if the bad bit error state flag is set for the stream. Notice that this function is not the exact opposite of good, which checks whether none of the error states are set. Oh, okay. So never mind. I do want to say it's not good instead of bad, because there's other bits that might be set. Let's go to good again. Flip-flopping. Returns true if none of the stream's error state flags set. Return value and example. Oh, good, and they got an example. So, int main string stream.clear the good bit, clear the bad bit, fail bit, and then print state. This isn't actually telling me how. Check this. I guess I'm just going to go straight up and do a OF stream tutorial and quickly reacquaint myself with how this works. Here we go. Open a file. Good. And optional flags. Yep. We've got out and we've got trunk. All of these flags can be combined. Yeah, no. And now let's do generally open 3 classes including instructor. That, yeah. Yeah. So it's not saying. Oh, here we go. The following member functions exist to check for specific states of a stream. Returns false in some case, in the same cases in which calling any of the previous functions would return true. But the good and bad are not opposites. Do I? You know what? I got to call clear. It occurred to me. It's possible for this the same object to open a file later. So if the stream is open, I should also call mstream.clear. Clear. Right? Clear. With a semicolon, of course. I guess there's no harm in me putting it above, just always clearing the bits. And is that literally all it says about good and bad? Fine, I'll just have to do a little more reading. So good means that there's no errors. Functions to check state flags. Oh, I see. So these functions query one or more of these. So what error state flags? RD state. Oh, okay. So RD state then gets me the value to perform bit operations on. Right? Public member functions, yeah. Okay, so this actually gets me the value with which I can compare. But I guess I don't have to. I might as well just use good, EOF, fail, bad, or whatever. Cool. So we got good bit, no errors. So if it's not good bit, then I can check each of these. So for some of the history, we're good. I'll do return error code success. Else, and I guess we'll do some elf ifs. Because these are bits, I can't do like a switch statement because I have to do bitwise logic on each one. Whatever. Mstream dot stream dot. What else do we got? EOF. Well, EOF is not something that you would expect to reach upon opening the file unless it was empty. So I'm looking for fail bit. Can you not actually tell the reason why fail bit was set? About bad. Because what I want is I want to actually be able to tell the dev why the file didn't open if it didn't. And it kind of looks like the API here just tells us that it didn't open, not why. Here we go. Oh no, does this handle it through exceptions? Is that why I'm not? I hate exceptions. It'll actually be kind of a bummer if I have to deal with exceptions here. I think I'm probably going to leave exceptions enabled for my engine. I know that like everybody in the world wants to disable them for game development purposes because there's just a little bit of overhead that you don't need if you're good at what you do. There's an exception of member type failure if the function fails and member exceptions. So, okay. Okay, and that's where I get the error code. Okay, great. So I guess I have to wrap this in a try block. Instead of having a way for me to simply check what the error state is, it throws an exception, which means that if I don't handle it, that a failure to open the stream will cause it to crash. Great. I'm wondering if forever ago when I started doing this API, I wonder if that's why I didn't just use IOStream, is because it works this way. Exceptions are, good in theory, but they add a lot of extra steps to doing simple stuff. All right, so I got to wrap the open in a try block. I'm going to catch std. What do I have to do std? It should be static, right? Failure should be oh, I'm sorry, it's a class, so I would do std of stream failure. Failure. Right? Yeah, and I'll catch that by const reference. std. So at this point, we've got a failure to open the file. And we would use e.code to get the error code. And that can be type std system error. I'll use either the error code passed to the construction or equivalent. Is this a platform specific? Could I be using the same codes as before? It kind of looks like I really want a list of error codes so I can just handle them. Oh geez, surely somebody has a list somewhere. Or can at least tell me that they are the same as what you have for the platform or the C API or something. Okay, so I can get it from str errors. So that actually makes these the same errors that I was handling before. Just took forever to confirm that. But that's what I've got commented out now, I believe. Yeah. Yeah. Cool. So this should be what I need. I guess we'll have to do some tests to see if that's actually the case. Error no is going to be replaced with e.code. Oh, what? What's up with this? Constancy error code. Pointer to a bound function, maybe. But do I have to, is it actually a function? Oh, I guess so. Okay. Maybe there's a I guess I'll have to use str error because I'm getting all kinds of mixed messages. Man, I thought this was going to be a way smoother stream. Oh, okay. So I've just discovered some good news. Actually, you don't need to catch an exception because it doesn't throw an exception unless you actually explicitly ask, which is perfect. That's exactly what I wanted to hear. So that means that I could use str error probably to get what I need. Let's go back to basic OF stream. So we would then use str error, I suppose, to get the error. Okay, so I just use error no compare. It seems like way harder than it should have been. So I can actually literally just keep using error no, and that would actually catch problems. I guess I'll have to try that and test that assumption, but I can actually get rid of this try catch block, which is great news always. Oops, shift tab to bring that back. Oh, now we've got the open operation. We can check error no whether there's a problem. So we got e-access for permission denied, ent for doesn't exist, and unhandled errors here for other kinds of error no's. So what I'm going to do is I'm going to wrap this all in if mstream is good. And then if mstream is not good, and then I'll do else return success. That should be all we need. Control KF. We can finally move on. So if the stream is not good, we check for error no. But if I was following that description of the good bits and bad bits correctly, I may actually want to be using fail instead of good. Returns true if the most recent IO operation completed successfully. EOF bit, fail bit, bad bit, good. So fail. Having a little bit of a hard time parsing this. So fail is false only when all of the bits are false, or when just the end of file bit is false. End of file, fail bit, bad bit. So fail bit. Okay. The fail bit is set by the following stuff, and yeah, that's all right. We already know most of this. Fstream open, and okay, so fstream calls fail bit if the file cannot be opened, and the fail bit if it cannot be closed. That's the information I'm looking for. Does it not set? It doesn't look like it sets the bad bit either. Okay, so this tells me that I actually only need to care about fail. Because good can return false when we've reached the end of the file. And if it's an empty file, that's probably okay. Yeah, so what we'll do, instead of checking whether it's not good, we'll check if it is fail. Because I want to catch that circumstance where the EOF bit might be set. But that's okay, because we're going to be writing to the file anyway. Then bad bit, there's a lot of details in here. Bad bit. Non-recoverable errors occurred on the associated stream. Specifically returns true if bad bit is set in already state. But as we had seen in the page where it listed all the conditions that would lead to the bits being set, here. The bad bit occurs when writing initializing with a bad pointer, I guess. And when flushing goes bad. Yeah, so that's good. All right, so I think I've checked my bases. So instead of doing if it's not good, I'll say if it's fail. And then If it's not fail, then we'll say success. Otherwise, we'll check for the error codes. And I specifically care about permission failure. Does not exist. And then I have a catch-all in case there's something I'm not handling. Cool. So that's the file open. The error handling is good. I should do this a little differently though. Return. So m error code equals error code dot success, and then we need to return m error code. So we're catching all the different kinds of errors that we have caught. And that should be that. I'm going to, oh, I already have returned to the bottom. I'm going to leave this stuff here for the moment in case I need to refer to it later. I doubt that I will, but you know, better safe than sorry. And that's open. Now I need to handle close. Is close in the, oh yeah, it's in the platform specific side. I think that's going to have to be, though. I'm going to have to leave that on the platform code because most of this involves moving the file to the correct destination. So closing the file is not all that hard. I would just call the close operator on the OF stream. But I would need to then get the path is wide, pass it to move file, and yeah, so I'll leave this as it is. I will do if m stream dot is open. And I've designed this so that if you call close and the file is not, if there's not already a file open, there's no harm in calling close. So you can call close just in case you're unsure whether there's an open file. And then we don't need to track m as open anymore. We just need to call m stream.close. And that'll automatically trigger a flush if there's any remaining characters in the buffer. And then do I need to check the state of the stream after I close? Fstream close might set the fail bit if the file cannot be closed. Honestly, I'm not sure why that would happen. Having to Google yet another noob question. Okay, so I guess that sometimes it will fail to close if somebody like rips out a hard drive or something, but there's not really anything we can do in that case anyway. So I guess what we may as well do is do if mstream dot fail, then we will say EP error text file writer close. And we'll say could not close the file. I suppose I could provide a little bit of helper information here. File, because I have access to the path as a member. That would be as, oh, I forget the name of it already. Native path, temp file native path. And remember that we're still writing to the temp location right now. After we've closed the file, that's when we go through this stuff to move it. So when I'm reporting the error, I'm reporting the error of not being able to close the file to the temp location. I think though, if it does fail, it's still, the file still, or the file handle still is considered closed. So I don't need to do any handling to force it to say that it's closed. Vectorly calls, buff. If an error occurs during operation, fail bit is called. Yeah, so I think we're good here. I can just call open again on the next file, even if there's a problem. All right, and then the rest of this logic should still work fine. I've got the new path is wide and temp path is wide. I got to convert the destination and the temp file to wide paths so it can work with the Windows API. We're going to be replacing the file in the destination. Later on, I might provide an additional option to not do that, but for the most part, I think any situation where you wouldn't want to write over, you can just call file exists first to check whether it exists, so you're not overwriting yourself. And then we moved to the destination. Yeah, that all looks good still. So I think that's all we need for open and close. And then last but not least, the whole reason why we're doing all this, I want to get the insertion operator writing correctly. Let's go back to the class. The insertion operator is an inline, so it's all in the header. And then I think I want to still keep, let me think about how to handle this. Actually, we don't need to construct string stream anymore, because the whole point of that was to allow us to construct text using the ostream operator. But now we can just use that directly on the output stream. So we can go m string data. And I think that's literally it, right? Yeah? This hasn't changed color yet. It's making me think there might be a problem, but that's totally fine. And the rest of this was all just a way for me to convert it back into text to send back out. So yeah, I think that's it. Simplifies this code quite a bit. Comment that out. And now this will go into the stream, go into a buffer, and then be flushed periodically instead of being written directly to the hard drive, which is what we want. I still have the error handling for files open. Oh, I think I know what the IntelliSense is off, because m is handle open is not a thing anymore. We got to use m stream dot is open. Cool. We've got m, if the stream is open, then we push it out. Else we push out an error message. I don't think I want to crash the application in a situation like this. We just want to keep rolling and log the error. And that, I think, is that. If we've implemented this correctly, then literally everything will work identically, except for it'll be more efficient writing. So I'll press F5. Let's see if I broke anything. The file API is used in quite a few translation units, so it's having to recompile quite a number of things. Okay, so that seems to be working. And if it is working, then the templated write test file and the test scene serialization file should be loading correctly, and they appear to be. I don't have any files in the temp folder. This is just tracking that Visual Studio Code was aware that there were temp files, but they're already gone. just to triple check that. Yeah, because as soon as I close this, then... Oh no, they are actually temp files. Oh, but what are they from? 47. Oh, this must have been something left over from something I did today in 3 in the afternoon, so that's fine. But yeah, if we were to just delete all that stuff again, so we don't have anything in the data folder anymore, close the game, there's F5 again, and head back, those folders regenerated. I got nothing in the temp folder, and I go into the user data folder, I got those files written, and they are writing correctly. So sweet, everything seemed to have worked out the first try, even though it took a while to get there. We got all the stuff being written from basic types, including pointers and null pointer type. We've got C string, std string, pretty print containers. This was a vector of 3 integers, and pretty print automatically gives us the ostream operator to print out containers like that. And then this is the custom ostream operator I wrote for my own vector3 class. And the YAML file reserialized the scene correctly. Perfect. So that's that. The only other things to look at now would be to do the same thing for the file reader, the input, because currently that's not taking advantage of an internal buffer either. So I think I want to do that as an IF stream. So I'm going to refactor that. And I guess we should confirm that these errors are correct, or that these errors still work the way that they should. So first, opening the temp file. I brought this over from opening up the file reader originally. Does not exist doesn't actually matter here, because the whole point is that it'll create it if it doesn't exist. Permission to die would mean that we can't write to that folder, I believe, which realistically we're not going to see that. We're not going to see that as in a shipping game, because the API that we use to get the temp folder guarantees already that it's a file that we can write. Or write to, but just for the sake of it, I think I can test it by changing the permissions on the folder I redirected to. So we go to data, temp. I'm going to try changing the permissions here. Advanced. Do I just click this twice to make it read-only? Okay, read-only, and let's see whether that's a problem. Okay, and it seemed to build and launch fine. I didn't see any error messages in the other. What time is it now? It actually seems to be still writing to that folder. So, man, how would I simulate a permission issue? When I'm running as an admin. You know, whatever. I'll leave this as it is. If the mstream.fail triggers ever during an open, then I will get an error code. Because I'm using an if-else statement within the fail bit check. So I'm good to move on from here, and then we can worry about the rest later. Now going to go back to file, we're going to go to the file reader class this time. Here we go. And I want to do the same thing inside of it. We're going to ditch the m handle and M is handle open. I still need the line number, I believe. And whether, we don't need the end of file flag because that's something we can get from OF stream. Is the line number something we can get from, sorry, IF stream, not OF stream? Streams, basic IF stream. We got, oh, didn't mean to make a bookmark. So we got EOF, we've got line for getting the line. I don't have get line number, so I actually do need to leave the M line number member, and there's increment that every time we get the next line. Okay. There's admittedly less of a reason to create the wrapper for text file reader in this case. With reading files, we do directly access the file. Probably the big reason why we would use the wrapper is because of the virtual file system. So that way we provide the path to the platform generic file location. So the letter C for the contents directory, the letter U for the user data directory, and so on. And for platform generic error codes, I guess. But mostly because it's mostly already written, and I'm not really too interested in scrapping the whole thing just for the sake of scrapping it. So let's do std. That would be if string for input. M string. That's going to be where we have the return end of file flag. We would actually just wrap it with M stream .eof, which is a function that returns bool. And now we just need to get into open and close and start fixing those up. So opening this up, first we got the M is handle open is now replaced with M stream dot open or dot is open, and we close the previously open file if we are opening a new one, and then we still need to keep the native path to store the native path here. We don't need to keep hold of the native path like we do with file writer, because I'm not going to be referring to it when we hit close. We don't need to move a file the way we do with file writer or text file writer. And then this whole bit can go down the hole. There we go. Because we are now using the mstream to handle this. So we would go mstream.open. Same business as before. We would provide the path, which is now native path. And then we need to provide the open mode, which in this case would be std iOS base. For text, so we don't need that. We need out. Wait, out? In. In. I am being tired. And then I don't think we need any other flags, do we? Always check the docs while I'm working with the thing. Open. And okay, we got seek to the end of the stream, which we don't want. Open for reading, open for writing. We're not discarding the contents of the stream. Yes, we just use in, and that's it. Okay, the stream is open, but now we do need to check for the error. In this case, we would be using the error no. We would use if mstream dot fail. And then comment this stuff and format it. Let me double check the conditions that fail might be called. Calls set state fail bit on failure. So that should be correct. Calls clear on success. So I guess we don't need to call clear before we do all this. Going back to text file writer, when we had text file writer open, I did call clear, I think. Oh, that's not on this file though, that's on the file.cpp. Now I'm thinking, do we need that? Stream doc there. I guess so, because if it's successful, yeah. But what I'm going to do is I'm going to be moving clear to be what happens after we close, which has to be platform specific. I forgot, due to all the moving and stuff we'll have to do. Save text file, open, close. So we would mstream clear at that point, close and clear. And we'll do the same thing for closing on the file reader here. I mean here. Close. So we'll come back to that in a minute. The open is, I'm just remembering now that the open is actually on the platform specific side, and I don't think it has to be anymore. Let's review. Text file reader open. Yeah, no, we're not using any Win32 API calls anymore, so I can actually just cut this whole thing and bring it back to the multi-platform file. Put it right above text file reader close. I'll leave this stuff commented out for the moment, but now this will be available for the Mac build. And coming back down to close, we got to replace the Boolean check with the mstream dot is open. And it's not an error condition if you call close on a file reader that's already closed. So I don't even bother putting an error or warning in there. We don't use fclose anymore. We use mstream.close. And then I'm sure that the close function is effectively the same as the other. Yeah, it calls fail bit if there's a problem. So let me go back to the close for the writer, and I'll just copy over the if stream fail stuff. Here. Oh, you know what? I just realized something that I probably messed up in the other close. which is that I'm clearing the bits before I check it. That's that would have been a problem. There we go. Check yourself before you wreck yourself. And yeah, I think we're good for that. Here's the close operation again. Why is this? Oh, mtemp final native path is not a member of this. I'm going to leave that without the file name. This is a situation we should pretty much never ever see, is a failure to close an already open file. If we have an issue with that, I don't know how much more help it would be to know the path, and I don't want to bother saving the path as a member of this. Except, can we, I haven't thought about this, do we have a way to get the path? No. Yeah, so let's not bother. Here we go, we got open. If it's open, we close it. If the fail bit is set, we print an error message. And then we clear the flags for the next time. And we don't need to bother with have close or if is handle open anymore. Okay, cool. So that's open close. And then we just need to deal with the reading. So we got read next line. You can see how much more complicated read next line was when I was handling the buffer myself. I would literally, just to review how I did it in my previous naive implementation, I just did a character buffer of 200 characters because I was thinking, you know, most single lines are going to be less than 200 characters. And then I would use fgets to get a string, and that reads up until the null termination character. And then if it wound up being more than 200 bytes, I would just do it again and then push it to the back of this return val. And it was not really efficient at all. What ifstream is going to do is it's going to probably, my understanding is that it maintains a larger back buffer. So it'll have more characters at once. And it'll more efficiently spread out the reads from the disk, which is stuff that I want, but I don't really want to bother implementing myself, because somebody already did that and packaged it up into ifstream. So I guess the first thing I need to do is comment out everything. I think literally all of this is done now. I do need to do a check for whether we're at the end of the file, and for whatever stupid reason, I had made this an assertion instead of a warning. I had yeah. Boy, that's not a good way to do that. If you accidentally read the next line without checking whether it's at end of file, like that's a bad time to crash the app. It's not, I mean, the app can totally move on without any problems at all. You can just put a warning up to tell the dev that, hey, you're reading beyond the end of file, and you know, fix that. But then you can still test out other features that might be working in your current build. So what I'll do instead is I'll do if, and it'll be mstream.eof. Yeah, it's a Boolean returning function. If we've reached the end of the file, then we'll do ep warn for the warning logging level. Do text file reader read next line, attempting to read beyond EOF. And with this warning, I think actually, because this warning is going to be fairly common, I would imagine. I probably should put in the work to get the path of the file to display which file we're trying to read beyond. So I'm going to actually add a member here, or I'm going to start using the member and then add it where it needs to be added in the declaration. So that way we can actually tell the developer which file is not loading. And actually, it might be more helpful to not make it a native path, to actually use the virtual file path, because that's shorter in most cases. And it's actually what the devs typed in when they were typing. It's not going to include a whole bunch of extra letters and folders to the directory that they're working in. So let's go ahead and add that member. We're back at the file waiter header, stream header code line number. I will put this right above string empath. And then empath needs to be set when we go to open the file. So we go to open. And we'll call empath equals path. Cool. And now we've got the path as a member. And we can, when we do the error message for reading the next line, it'll actually refer to the path and tell us which file they're trying to read beyond the end. And I might as well go back to that error message that I wanted to do this for before. That was for, I guess this is in this file now. Text file reader, was it an open? No, it was in close. Right. When you could not fail to close, which is a pretty rare circumstance, but I have the path to put in the error now, so let's do it. And then they can see the file path that didn't open. They won't see the exact, the native path, but that's okay. Should be good enough for them to know which file they were trying to open from which directory. They'll know where their working directory is. And if we go back to read next line, amazingly, I think all of this is completely useless now. Oh, I still have to add I still have to actually add the stuff though. So I need a return val, std string return val, and that's going to need to be equal to. I think if I get the next line, it just returns a string. So I just get line, basic string get line. Or no, it gives us a C string, or a pointer to a C string. Pointers to the character string to store the characters to. Oh, so I actually have to provide it a buffer then, and provide the address of it. Extract characters, tell a line or tell to know. So I'll still need to do a sizable buffer to fit the whole line. Is there a way just to get a pointer to the string in the back buffer? Because I hate string copies. I always hate string copies. Put back, get line. Okay, there's actually an alternative here that I think I like better. Under std basic string, there's a class that, or a class function getLine that will take the stream as a parameter and then return the string. I think, at least I think I'm interpreting that right. std string name, we use getLine with the stream as the first parameter, the string as the second, and then it's got it. And I kind of like that better because I don't like the idea of having to allocate a buffer that might be too small for the line. But let's see if there's I want to know whether this actually does a copy. If this does an unnecessary copy, then I may as well just do the other way and do my own stack allocated buffer, which is way faster than heap. So it looks like it just loops through the characters and then calls the strings append method. So it's appending each character one by one. I don't like that very much because it means that every threshold at which a reallocation would occur, we will hit. Because we'll start at a string with nothing in it, and we'll be adding every individual character until it has to double in size, then double again, and then double again. So, I mean, that would be okay as long as we reserve enough space in the string. But now I'm kind of thinking that I want to do this as a stack allocation instead. Just use a regular C char array. But I still would have to package it up as a string and then send it out. So what I'll do is I'll make a string return val, and I'll just make sure that it has enough space in it. So I can use the constructor for the strings. What I'll do is I'll give it like 200 characters or so, something that's likely to be larger than most lines that you'll find in a file, in a text file. And then if that's still not enough, there won't be a crash, it'll just reallocate. Cool. And then we can pass that. We have to pass that back by value anyway, because of the way that the API is set up. Read next line. I'm not sure that I really like returning strings by value, but instead of using like a function where you've got a pointer to a string and then you directly construct it in there, but it's honestly probably not going to be a huge deal in a shipping game because we're not even going to be using text files for the most part in a shipping game. So let's get the constructor just to double check which constructor we would use. So I think we would use 2 or 3, and we would use 2. We got the count and we got the character. So, and going down to the description of it, so it constructs the string with count copies of character, whatever. Alternatively, we can just construct an empty one and then call reserve on it. That might be better. unless reserve also fills the entire buffer up, in which case it's a wash. Yeah, I think I'm going to do reserve on it because it's going to not fill the buffer up. It's just going to say, hey, make sure that you've got a buffer of this size. Probably it'll initialize the memory anyway, but I'm okay with that. That's something that you can't really avoid with allocations. So I'll do return val reserve. We'll want to reserve enough to handle any reasonably sized line width. 200 characters is a lot. Like for comparison's sake, if we go to like something that's got really long lines in it, like my GLSL parser or preprocessor, jers.cpp, like some of the longest lines are like, that's 137 characters. So 200 is more than most text files could need. I'll do 250 just because that's 250 would be yeah, seems like a good round number. So I'll come back to this guy. We'll do 250. And now that buffer's got enough space. So if we do an append operation that would normally cause a reallocation, all the reallocations that exist between 0 and 250 would be skipped because we just did it all up front. Well, you don't attitude. Sorry, I totally missed you there. I don't pay too much attention to the chat anymore, but yeah, thanks for joining in. Yeah, we have a great night. Okay, so we've got the return val reserved, and then I've either got to use the new line. Let's do mstream.get line, which provided a pointer to a C string. And it fills it up, or I would use the other. I'm gonna use the other, and where it'll append each character, which I don't like the I would prefer just to have a call that just copies it all. But would that be better? Let me think about that. If I was to do stream dot get line, I could pass it return val 0, but I don't know how big the line will be. I feel really bad for not missing or for not catching that chat. I'm not really advertising like this stream as like a show. I'm just kind of using it as a place to work out loud. So it's quite a lot to see people actually popping in and saying hi. Yeah, if I was to use getLine, where I give it a pointer to the underlying array, I wouldn't have an easy way to resize it. Well, I guess I could, though. Let me think about that. If I was to use, instead of reserve, use resize, then it would be a 250 character long string. So if I queried return val.length, it would be 250 characters. If I fill that up with null termination characters, then copy in the null termination or the null terminated C string from getLine, I can then just call a resize. But that would involve me going doing a reverse search from the end to find the first character that's not a null termination character. So never mind. I'm just going to use the other getLine, where I pass the m string, and then I think I just pass return val by reference. See if that screams at me. It doesn't. Let me double check the one here. Got a name, string name, cout, getLine cin name. Yeah, so you just pass it in by reference. So, right? Yeah, there's the little ampersand. Cool. So that should be that, and then this will be. The worst case scenario would be that it has to reallocate once, because if the line itself goes over 250 characters, it'll reallocate. But yeah, that should be fine. And then at this point, assuming that it was successful, we'd want to do line number plus plus. But let's confirm that. All right. So it automatically will check whether the in file condition has occurred. It will set the EOF bit on the stream. So we'll need to check for EOF. The next available input character is delim. I'm not specifying delim, so I think by default that's just going to be getting the end of line. Can I do a max size? Maybe that's a thing that I don't. Think about enough. Due to system or library implementation limitations. Yeah, that's not very likely to be hit. So I pretty much don't need to worry about that. So I guess I need to check EOF bit for obvious reasons, and then the fail bit in case the we hit the maximum limitation, which, like, frankly, that'll never happen, or if there was some other failure. So let's do that. If we actually whether or not we reach the end of the file, I need to increment the line number. If mstream.eof, whether the EOF bit has been set. Then what we need to do is, do we need to do anything? Previously, I would set the member. If we reach the EOF, we would set the member. And I don't need to do that anymore because now I directly check the flag. Yeah, so let's leave that. We need to check the fail bit though. And if we do have a fail bit, we know that might happen because of implementation constraints or whatever. There we go. That's the EOF bit. If it reaches the end of the stream as opposed to reaching the null termination character, yeah. And formatted input functions. And reaching the end of the stream, yep. STD get line if the function extracts no characters or if it manages to extract basic string max characters or max size characters. You know, it's actually okay, I think, if it doesn't extract characters, because when you're using getLine, I'm pretty sure the new line character is skipped anyway. So if you're on a line that's just another new line character, like you just press enter a couple times in a file, then we would expect it to receive 0 characters. I guess we'll need to test that. But for now, if we get the bit failed, that means that I'm going to assume that the only situation where it'll come up that's a problem is if there's like a corrupted stream or we actually have hit that implementation limit. So we'll do EP error. I'm going to need to be redoing my error reporting soon anyway, so that I don't have to keep doing this where I type in the function name, among other problems that I have with it. And I would say, I guess I don't know what I would say. I don't know whether there's a failure to extract characters or what. Failure to extract characters is a lot more likely, but and then I think I can use a generic call to get the message telling us exactly what's wrong. Would be m stream dot I'm trying to remember where I saw it. Oh, I think I might actually have to to turn on exceptions and catch the exception to get the message. I think that's where it came from. Am I misremembering this? got it. Yeah, so we use str error on error no. Okay. And I think that'll compile. There's a non-zero chance that it'll fail to compile because of the SBD log. Doesn't seem to like putting things that have macros in them in the as the argument. But yeah, if there's a failure to read the next line or something like that, then I guess we should immediately close the stream and then move forward. So std, what am I doing? Stream dot close. Actually, to catch all of the other stuff that we need to track when we use our close. Yeah, because we have error catching for the close operation as well. We'll just call close the class method. And let me throw that on a new line. Okay. And at this point, I decided we will always increment the line counter, because if we don't, then we will have still have the previous line number when we go to check what line number it is. So that, I believe, is literally everything. We've got the get last error is just returning the error code. Do I need to think about setting the error code from the read function? Was there a place that I might do that? I suppose I could from as before, like in here in the failed condition. But that involves interpreting the error number, and I don't have any idea what to catch. Let me do just to provide the actual error number, then the description. Okay, cool. So I guess it's a matter of truth time, or a matter of what's the moment of truth time. Oh my god. Press F5. I have plenty of places in the engine that rely upon the text file reader. In particular, the INI file parser relies on it, so I'll know right away if it's broken. Oh, we got a failure to compile there. So, what did I screw up? File reader open. I don't return the error code. Whoopsie. Let's do that. Return an error code. And was there anything else? Read next line must return a value. Oh, yeah, rookie mistake. I didn't return the return val. The whole point of getting the text is to return it. Okay, we got an assertion failure. And a crash. What just happened there? Exception thrown, fatal. Enterprise exceptions fatal error at memory location. But it didn't break for me. So we have an uncaught exception. Oh, that's the wrong main CPP. Right, I need to go to, I called it entry point 132. So, interesting. The entire main loop within WinMain, so this is the actual entry function for my engine, for all Windows programs, is WinMain. It's wrapped around with a try block, because there's a couple of exceptions that I actually used to use, and I'm probably going to need to get rid of them at some point. But the exception that was thrown, that was uncaught, did not happen here. Oh no, it did. Interesting. Hang on a moment. We had a fatal error. I should add a debug break to these. So what's happened is that this is the fatal error. If I go to the output, enterprise exceptions fatal error. So actually it did trigger here, but and so it must have been one of my own exceptions. When do I throw a fatal error? I don't do it often, like rarely at all anymore. And if I do, I usually will have a helpful message pop up, and I didn't see one this time. Okay, so this is probably an issue coming from the INI parser. The INI parser is kind of a mess, and I've actually kind of got to go back and redo it at some point. I've learned a lot about parsing since I wrote this. Like there's unnecessary string allocations all over the place and things like that. And something that I apparently didn't do very well is I threw some fatal errors in here that, or is that the only one? I think it's the only one. That only crash the program, and I don't have a mechanism for for dumping out the log to a file. So this message pops up and then disappears immediately. I'm assuming that this is the one. Just to test it, I'm going to throw a breakpoint on it and see whether that's the one that catches. And it is. So let's take a look-see. A required INI file cannot be opened. The game cannot continue. So this call, if I go to the stack, was from loading an input context file. And I marked when I create the INI file reader, which is based off of, it's like an extension of the text file reader that we're working on now. You can tell it whether the failure to load the INI file will be fatal. So I marked it true in this case because it's an input file. When you're loading up an input file, so that's a text file that actually tells the engine which controls do what. If you can't load that, then you don't have a way to control the game. So I said to mark it as fatal if it doesn't even open. I have a better way to handle that in mind. I just haven't, I'm not quite there yet. I will be soon. If we go to open up the enterprise folder again, and go to my content folder here where I've actually got this stuff, test input .ini is the file that's not opening. It obviously opens okay. I've been using it this whole time to press escape to exit, but apparently there's an issue opening it this time, and I just don't have great error handling for breaking on that line. I should stop, go back to the breakpoint, which was on INI CPP. And before I throw, I should, just to make this easier, until I go to fully fix this parser, I'm going to go EP break or debug break. This is the macro. I have a little helper macro here that allows me to put a breakpoint in through code on MSVC on Windows. That's done by invoking the compiler intrinsic debug break. My understanding is that there's actually a problem sometimes that can occur when you throw it, where it'll like miss an instruction and sometimes miss debug break. So I throw an OOP operation in there prior to calling debug break. That's something that I've never really had experience with, but I've heard that it's a problem and people put it in their own engines. So I do it too. And then on macOS, you do it. You can trigger a breakpoint in Xcode by using an assembly instruction int $3. But yeah, that allows me to version control the debug break and just leave it in here so that it'll always debug break even if I don't put it in the editor. And let's take a closer look at the open operation, because that's what's going wrong apparently. So go to file.cpp and let's take a look at this. So I'm going to step through the whole process of opening the file. First, is this the right file? Yeah, content folder /testinput.ini. Step over. MStream is not already open. We are storing the path. We are converting to the native path, and so the native path actually goes to the hard drive and all the paths all the way up to the file in Windows. And then we call open. So at this point, ideally, the file will be open. I think this lends itself well to inspection. What happens next? Apparently it's okay, and then I go to return error code. Oh yeah, okay, another one of those rookie mistakes. I never set error code to error code success. It is still equal to null before we get here, and it's set to null by default. That's what the initializer has in file.h. Yeah, so what happens is that it does open successfully, but it does not report success. And so INI reader is saying that a file that it thinks that the file failed to open, and then it crashes because I told it to make those things fatal. All right, let's do this again. And hopefully this will just be it. I forgot to remove that breakpoint. Continue. Okay, that's looking better because it's not a crashed thing. But we got some errors in the log. What do we got? Text file reader, read next line, read failure detected, file will be closed. Error 9, bad file descriptor. And then we call close, and we can't close it because of bad file descriptor, which apparently, so I guess that means that the INI, oh, that's weird though. It apparently did open correctly because I pressed the escape key and it quit the program, which is defined in the text file we were opening. That's here. Like if I made this a different keyboard key, then it would close with that. So it's apparently reading enough of the file to work. It must be breaking when it gets to the end of the file. So we got read next line. This guy. So read failure detected. This is the message that we called. So let me put a breakpoint there. So this is where we have the problem. Line number is 31. And if we go inspect 31, it is actually the last line. So we've reached the last line and the fail bit was set. Does that mean then that it was set because the end of file was reached and there's not even a new line character in it? Because I remember that was the other condition that might have been a problem. Can I just check if I go to can't I just double click to add a value to, or an auto is just not where to do it, I guess. Or is it an add watch? I just want to type in an expression. I guess it's add watch. Okay, and then I'll type in mstream dot EOF. So it did detect the end of file. Because EOF, when I invoke mstream.eof, it returns true. So okay, so EOF bit is set when it reaches the end of the stream, as opposed to reaching the terminating character. If the function extracts no characters or it reaches the basic string max size. So I guess the EOF is being set because we reached the end of the line, and fail is being set because it didn't give us any characters. The fact that we are only encountering this problem on line 31 instead of line 20 and 28, where I don't have any characters, tells me that it counts the new line character when that it considers the new line character before the fail check. So it's possible that if we've reached the end of the file, we'll have the fail bit set, and that's okay. Let's stop right there. So EOF, mstream EOF. Okay. So I think in my head, I did a step and I didn't actually do it in real life. That is to wrap this in an else. And return val would need to be declared above to get it in the outer scope. So yeah, because I was thinking that if we try to read the next line and we're already at the end of the file, then don't continue. Otherwise, we would proceed and call std_getLine. And I don't want that to be a thing that causes a crash. I want that to be something that we get a warning that we're trying to read, and then it continues on its merry way. So I just use an if-else for that. So I think I think that's probably it. I'm just gonna hit the debugger and rebuild and see if that was all I needed to change. Read failure detected. No, we still got the same problem. Error 9, bad file descriptor. And just quickly Googling what bad file descriptor actually means. I suppose with read next line, it would be helpful to have the line number when there's a problem. I guess that might be a little bit of a vague message. I'm going to put that on the back burner for the second. And go back to inspect where we were at. Before I forget, I'm going to add the line number. To the error message. Then we'll break on the line. Okay. So line number is still 31. We are in the else block, meaning that this must be immediately after reaching end of file. So probably on the same call that we reached line 31. But it would have to be, actually. That's a good point, because it's a M line number is 31 and it just incremented. So that means that the fail bit and the end of file bit was set in the same call. Because simultaneously there were no characters read and we were on the end of line. So to test that theory out, I'm going to stop. I'm going to add a space to the last character and press F5. And just like that, there's no error. So the fail bit is being set because there's no characters in the last line. That's actually a valid condition. So what I'll need to do here is I'll need to do if mstream.fail and we're not at DOF. I suppose it may be a little bit more natural to do a second if statement. I don't know if that. Yeah, I'll do it in the same if statement. So we'll do mstream.eof. And I need to put an exclamation point before that. So if we're not at the end of the file and we've got a fail bit set, then we'll move on. Otherwise, we will. Wait, then we will not move on. If we're not at the end of the file and we have a failure to read characters, including just new line characters. So a line can be empty before the last line. Then we will. Yeah. Okay. Good. So that should be it. I removed that extra space at the bottom of the file, and we should be reading it without any. No, there's a warning. Okay, what do we got? Could not close the file. Okay, that's the one I didn't expect to get. I mean, it apparently opened the file because I can still press escape to get out of the sim. So let's go to the close method. Close. So this is the one where I didn't expect the fail bit to get set at all from what I had understood reading. But I guess that's not true. If mstream is open, call close. Oh, I think I know what's happening here. The fail bit was set when we reached the end of the file because on the last line of the file there was no character besides the end of file, which means that the bit is still set when we get here, because I think I was assuming that close would clear the bit. Should I be? I guess that means I should be clearing the bit before I call close. That doesn't seem right. One of those things that I just don't have the experience to know the answer off the top of my head. mstream.close. So that would be ifstream. Okay, closes it, disassociating it from the stream. Ending pending output sequence is written to the file. That means it flushes. If the stream is not currently associated with any file, this function fails. Internally, it calls already buff close and sets fail bit in case of failure. Yeah, so it doesn't mention at all resetting the bit before. So it sounds like the problem is that the fail bit was still set from the close and we just didn't clear it before calling close. So we weren't able to detect anything going wrong here. I suppose that's probably it. I know that there was another location where I called mstream clear that might pose this problem. And that is the text file writer class, not the reader. So I'm going to go ahead and do the same thing for it, move it to clear above the close. And that way the close has the opportunity to set the fail bit with that being hidden. And that's that. No more errors. The file is still loading correctly because if I press escape, it still closes the program, and that's something that I can reconfigure with the text file. So it seems like it's fingers crossed better. Is there any other way that we might have screwed this up that I haven't caught for the moment? There might be, but I think I'm okay to move on at this point because the I did a pretty robust job of catching the extra situations, like if I don't have specific error handling, doing a catch or a message anyway. So like for example, if else. So if the stream bit .fail, then it'll always give me an error. So yeah, I think that's good. I've now got more efficient, cleaner file reading and writing using the stream operations. I can go into, I can do a text file writer and then write out anything that supports the OStream insertion operator, and it'll output to the file just fine. Like we see here, we got the overload from my vet class and then a pre-printed std vector, strings and values and pointers, and the pointer even comes out in hexadecimal, and yeah, it's going great. The one thing I didn't quite like about how this serialized was that the booleans come out as 1 and 0 instead of true and false. I think I'm gonna be okay with that because that's the way that that serializes when you use the stdc out anyway. And if somebody really cares to print it the other way, what they can do is they can just do like a freaking ternary operator and just output true or false as a C string. But yeah, I think that's broad strokes of what I wanted to get done tonight. Let me go to my list. I had a short list of things that I wanted to get done. Yeah, I guess the next thing to work on would be the INI writer and maybe approving the INI reader. Because as it is, until I just very recently got the text file writer going, I didn't have a reliable way to output INI files that I've modified. But now that I've got it, if I can get an INI writer going, then that'll allow me to do a whole bunch of helpful low-level things, such as memorizing where I last put the game window, memorizing the previous full screen or windowed mode setting, and things like that, which are like technically I don't have too much use for at the moment, but I will soon when I get to making that game editor. And it'll especially be important when we talk about being able to set the input correctly. Oh, I haven't even mentioned it yet. There's a whole scheme I have planned for INI files, which I haven't had a chance to use yet. So a lot of the problems that we have for exception being thrown if there's a problem parsing the INI file, those will go away when I have implemented a backup system. So the idea is that if you have a INI file that you want to load for configuration, the original copy of that file will be located in your content directory, probably some location where you got a known good copy, and the content directory is going to be the read-only location for your installation of your app. But I don't want that to be where the INI file goes. So in virtually all cases where you're using an INI file and you need to save custom preferences and load custom preferences, you're going to want to eventually be working with it in either the user's app data folder or the computer's app data folder. So that is the user app, the app data in the user folder, or the global one for I think it's just underneath like C Windows or something. I could probably look up the path. So the at this point I have the ability to just do /g or g/ in a virtual path. So like when we go to open up a file, you can say U to get to the user data folder, or G to get to the global data folder, and you can just access and write there. So a system that I'm going to need to be setting up soon, as soon as I got an INI file writer, is a way for Enterprise to automatically fill in those details. So the plan is that the first time you go to launch the game or whatever you've made with Enterprise, the read-only copy will be copied over to the user data folder or to the global data folder, depending on the use case. That copy will be the one that will be actually read for settings. And when you make an edit, it will edit that copy. And then if the user like goes in and deletes the INI, Enterprise will just copy the known good one back from the installation directory. So that way there's always a point of reference for the file. And I want to do this all automatically because INI files are one of the kinds of files that I think almost everybody's going to use for their preferences, just because they're so simple and portable. And I prefer them to working in the registry. Not that the working in the registry is very, very hard anymore, but it's just better to have a data file, I think, than have to use platform specific stuff to get into a plist file on Mac or get into the registry on Windows. So once I've gotten the NI writer going, I'm going to be implementing that process for things like input and things like, whatever. And that way we can start adding some of the INI files to version control. I haven't been doing that at all up until this point because I don't have any reason. I don't have any way to make changes without screwing up the version control copy. But if I got the backup system going where it copies it to a working directory and uses the working directory, then that would be great. That would just be, I could just version control stuff that I'm going to use all the time. Things like setting up the window the way that I want for debugging, and yeah. All right, I think that wraps it up for the stream. I don't really want to dive into these other larger topics tonight. So thanks for stopping by, the folks who have. Have a good one.